Right, what we're going to use is an alternative method for finding roots. This one can be unreliable. It has a number of little quirks, as in sometimes what you first guess at might be completely inaccurate. It may wind up zooming around, disappearing off to infinity. It might get close to a root and then disappear. You can get cycles where it doesn't fully work. So unless you've got a very good reason for using it, i.e. an exam question telling you to, it's not that great a use except in very exceptional circumstances. So what we need to start off with is the idea of what value are we looking for this to be, find the formula for this. And what this is talking about is trying to find the roots. And the roots are when the function fx equals 0. So what we do is we put in, so if we put in 0 into this equation, so we set this to 0, this function to 0, and what we can do is we can rearrange this so that one of my x's here becomes the subject of the formula. Now, what it means by iterative is if you were to put a value of x into one side, it will give you a new value of x as the effect. So that we've got three options here. If I do this one, where we get x is equal to x cubed minus 3x squared plus 5, and all of it divided by 2, we need to tell the difference between these two things. This is still an equation that will solve that. What the iterative formula suggests is if you make a good guess to start with, xn, and put it into here, if you start with a good guess and put it into this formula, it should give me a better guess. That's the hope. Like I just mentioned, it doesn't always work out. I'll give you a quick run through with this one. Actually, you don't need to calculate it yet. No, let's do the other ones as well. So that's one that doesn't work very well. Let's go for the second one, which is, let's look for the x squared term. So we're going to pull out the 3x squared, and we're going to call that n plus 1. And now we've got x cubed, which is of n, minus 2x n plus 5. So this is my nice solution, we think. Let's rearrange it. xn plus 1 is all of this plus 2xn up minus 2xn plus 5, all divided by 3, and all square rooted. So you can see the effect. Let's pull in a graph and have a look at it. So what we're going to do is we're going to start with a value of x is, so we can start with a value of x is 2. Here's our first guess. So we're going to create a table of values. We're going to use a calculator to calculate some values, and I'll show you how on this graph to represent it if you were ever asked to do something called a staircase or a spider diagram. They often get called staircases because of what you'll see in this one. So we're going to have a table of values. So we've got xn, and then we get xn plus 1 come out. Actually, let's do it horizontally because we're going to use the table to do it. So put xn and xn plus 1. xn starts with 2, we get told for this question. I'll show you what happens with this as we go through, so we don't need the graph on here yet. And I'm going to do 2, and I'm going to work my table going across, just to shape it. Now if you're asked to do this, what we need is a way to do it on your calculator. It's not a table function, because what we want to do is we want to take the answer to a calculation and put it back in. So what we have is, let's start off with 2 and put it into the memory. So my value answer on the answer key, oops, answer key down here, that's going to be whatever value is last stored, last calculated. Now you can do this, actually I'll show you a slightly tidier way. If we store this to x, second, store and say x, my value x now contains the number 2. Okay, that's my first value. What I can do is I can type in the equation we're talking about down here. So I need to do the square root of the whole numerator, so that is my x value cubed minus 2 lots of the alpha x, add on 5, and that all divided by 3, still inside the square root. Okay, that's going to calculate my next value for me. So press enter and we get root 3, but that's not too important, so we're going to go, this gives me my next number is 1.73. Now what we're actually doing by this is we've rearranged the equation so that we've got 2 equations. We've got the function x cubed minus 2x plus 5. Let's put it, so I can't do that yet. So this is the function, the green line, x cubed minus 2x plus 5, all divided by 3, square rooted. And it's got the same roots as my cubic. So the same answers come up when this intersects with y equals x. So we're saying x equals, this function has a solution here and a solution here, which ties up with the function. Now what I've just calculated is we've just put in the value 2. And what it's done is it's calculated the value 2, found out what the y value is, and we're now going to choose that to be my next iteration value. So my next number now is 1.73. What I'm going to do on the calculator is take the formula and tell it, after each time I press equals, to store into my value x. So I've still got my root 3, the 173. Press it again, I get my next iteration value, 1.50 to the nearest whole decimal number, but you can keep accurate because we're using our calculator. Press equals again, gives me the next iteration, 1.33. So we're on iteration number 3 up here, 2, 3. And what you can see is as these numbers are picked up, they start getting closer and closer to this value down the bottom here. If I keep pressing equals now, got 1.33, gives me 1.25, 1.25, moves on, and eventually you'll get to a point where the number becomes fairly stable. .21 gives me 1.207, which gives me 1.203, and we're now getting to the point where we know our answer is getting closer and closer to 1.2. So if I was asked for this to 1 decimal place, we would estimate. And they may say after 1, 2, 3, 4, 5, 6, so my 6th iteration gives me an answer of 1.207, and my estimate would be x as a root is approximately 1.2. And that's where this number seems to be zooming into. If you zoom in, this root is 1.2. So I could keep going lots and lots of times, getting closer and closer to that point. Okay, so that's that root coming out. Now, there's a couple of things that cause us problems doing this. Oh, by the way, this is the thing called a staircase diagram. So it's between your iterative formula and the y equals x graph. It's the y equals x that takes the last what we do is we calculate our last value. By using that y equals x, it takes it from an output and turns it into an input. Change the x value from that output to an input. And that's why they say match it to the y equals x graph and show what happens. Now, the solutions all come about depending on this having a good value. If I move this over to here, I think 3 is the number where it starts. Oh no, 3 is okay because it zooms in. Let's move my estimate to the estimate value up. There's the estimate. Let's see if it zooms in on 4. So at number 1, I'm moving that way. If you look at what's happening, each time I try another value, I'm getting further and further and further away. So it moves away from that. So not all answers are good. X equals 0 doesn't always give me an answer. So you've got to have a good value and you've got to have a good function. So let's have a look and see what can happen if we try this form. I'm going to try putting some good guesses in. So my iterative formula when I rearrange is a cubic, the green line. And I'm going to take a first guess at 4. And it zooms off to nowhere again. Let's try starting with 2. So 2, first time in, it zooms in. As I go to the second iteration, and third, and fourth, fifth, this one keeps going round and round in the same sets of values. It doesn't actually get closer to a solution. After 30 tries, we're still going round in the same box. And that's when the initial value was 2. Trying with initial value of 1, same function. It starts spiralling around and spirals outwards, and then starts stabilizing to, again, another pattern that doesn't come in. It's quite possible that sometimes these formulae may not give you solutions that will work. We can do the rearrangement for the cube, so we're going to do 3x squared plus 2x minus 5 cube root. So we need to rearrange that to give us our third iterative formula, taking the x cubed. See what happens with this one. So my x cubed comes out, and we've got 3x squared plus 2x minus 5. Okay, so we've taken all of this part away from the x cubed, and now when I do the cube root of this, xn plus 1 is the third root of my equation. You get this value. There's my equation. To the power 3, remember, is cube root. Starting with the value 1 again. It looks like it's going nowhere. Why does that keep popping up unnecessarily? So second iteration, third, fourth, and what happens with this one is it actually finds me a different route. Now it keeps cycling round and round and then comes back in on it. So this keeps bouncing in and out towards a route around minus 1.4. So when xn or x0 is given as 1, It leads to an approximate value, but we never get close enough to say about minus 1.3 something. It goes in and then comes out, but it keeps going in cycles to get round to that value. If I choose a different starting point, see where it goes to. So a different starting point, zooms in, zooms in, zooms in, and it finds this third root. So if we say x equals 2 as our first root attempt, we've now found another solution as well. It zooms into approximately 3.15, and it can zoom in, going through our numbers lots and lots of times. We could get to that value by using a table similar to this one. So this is what iteration is about. You take the version of the formula and you choose one of the x's. So if I put in here, we actually had find the roots of fx, x cubed minus 3x squared minus 2x plus 5. We can choose each of these to give us a candidate function and choose various numbers. Now what happens in the exam is you need to pay attention to what they are asking for. So if they say find me an iterative formula, where they show us xn plus 1 is the square root of x cubed minus 2x plus 5, all divided by 3. What you need to think is, that's what they want me to find, so let's reverse it to something looking more like my original function. So we want to get it into a single line. So I'm going to rearrange this by squaring both sides first. Is x cubed minus 2x plus 5 all over 3, and then if I think about multiplying that up as well, I now know which term they were using to choose their iterative function. So when you get asked to show the iterative formula can be this, we now know, begin with the x squared term. Okay? With this one, get rid of the cubed root, so we've got x cubed. Right, so I need to begin with the x cubed. If there's nothing there, I'm looking at that single x. Okay, so that's using the iterative formulae. They take practice, they take a lot of practice with your calculator. Make sure that you are familiar with using the function store and store back into the same x so it iterates round. Okay, that's what I actually put in. Okay. So quickly in summary, what we start off with is an equation, and depending on the form they want, if it's got a cube root and an x squared, or it's just a linear, if it's got a cube root, a square root, or it's just linear, decides which of these x's to rearrange to use to give you a form of the equation. What we're doing by making x equals to it is writing an equation that it has solutions when it intercepts with y equals x in the same place. This one actually has another solution around here which intercepts with that one. Then by choosing an initial value, we can put that initial value into x, type the function in and tell it to store that back to x. And what we're going to do is wind up every time we press equals, it gives us a next step to give us what we hope is a better approximation. So each time we go through, we get a new x out. That x gives us a better guess, we hope. It's not always reliable. It needs special care with the function chosen and special care with the starting variables, because some of these functions will disappear off to away from their solutions altogether. Some of the numbers might do it. Sometimes numbers and functions wind up creating a circular pattern where they keep going round and round, and you don't get any closer to a solution. But that is using the iterative formula.